Okay, today we're going to be talking about circles. And so the first thing is that what is a circle? A circle is a group of points that are equal distant from the center. And so they got to be in the same plane. And so these points on the circle are all equidistant from the center. And so it's comprised of a bunch of points, and we'll graph a bunch of points. Later on in the chapter, we'll put this on a coordinate plane. It'll be super cool. Well, for today, we got to talk about the vocab of a circle that is not on a coordinate plane. And so the center is going to be the most important point. And so everybody's equidistant from them. So that's how we name our circle. So we could call it circle C, or we could draw a circle and write circle C. And so that's how we would name the circle to the right. You name it by the center, and you can either use the word circle or draw a circle. The radius is going to be the distance from the center to the circle. There are many radii that you can draw, but a radius is just one of those that you could draw. And so the plural is radii. And so it'd be where it starts at the center and it goes to the edge. A chord is connecting 2 points on the circle. So take any 2 points on the circle and connect them, you'll get a chord. The longest chord you could draw would be the diameter. And so this is a chord, but it also has a name because this chord goes through the center. It's called a diameter. And so that would be right here. The length of the diameter is twice the length of the radius. If you think about it, the radius is just halfway across the circle. A diameter is all the way across the circle through the center. And so the word diameter is longer than the word radius. So that might help you remember. The radius has only several letters. Diameter has a couple more. It's a little longer. It's going to be twice as long. So the diameter is going to be twice as long as the radius. Also, all circles are 360 degrees. They're similar to each other. Okay, remember we talked about similar figures and the qualifications for that. Well, these are all 360 degrees. They're all similar to each other. To be congruent, the radii have to be congruent between the two circles. Naming the circle to the right, okay, this would be circle C. You can either write it as circle C, or you could write a circle and then write C. Tell if this is a chord, a radius, or a diameter. And so XZ, go ahead and look at that. XZ, that's right here. That's going to be two things. It's a chord because it connects 2 points on the circle. The point X and the point Z are points on the circle. So it's going to be a diameter. It's going to be a chord. Why is it also diameter? Well, because it goes through the center. Between those 2 points in the circle, it goes through the center, so it's called a diameter as well. CY is a radius. Okay, because it's from the center to a point on a circle. WX is going to be right here. That's going to be a chord. It doesn't get started at the center. It doesn't go through the center, so it's going to be just a chord. ZY. ZY is going to be a chord as well. It doesn't go to the center, so it's not going to be also a diameter. ZC. Oh, look at this. She's a radius. And then also CV is also a radius because they connect the center with the edge. If it connects 2 points on the circle, it's automatically a chord. If it also goes to the center, you call it a diameter. If it is just between the center and the edge, it is going to be called a radius. All right, let's keep talking. Well, I told my students in class, we pulled out a grid and we talked about if you look at a circle, okay, if you look at a circle, the question is, if you take this diameter and say, okay, the length of this diameter is a certain length, how many of these, if you kind of wrapped them around a circle, how many would it take to go all the way to the circle? And people were guessing, how would we know? It's a little bit more than 3, isn't it? In fact, you know how many of those it would take? Exactly 3.14-ish. So it'd be pi diameters to get around the circumference of any circle. So if you look at the formula, this formula is circumference equals pi times the diameter. That means to get around the circle, to find the circumference, you do pi, or 3.14. There's a lot of decimals in your calc. 3.14 times the diameter. So that means it's roughly 3 diameters to get around any circle, no matter how big or small. And so, or you could do 2 times pi times r. How come? Well, the 2r is going to be the diameter. And so the diameter times pi is the same as 2 times pi times r. So you can just kind of reorganize it. 2 times r is the diameter, which is this, and you times it by the pi. So 2 times pi times r is going to be the same thing. You double the radius and then times it by pi. That'll give you the same answer. So you may be asking, like, how did they come up with the value of pi? Well, the truth is that, you know, even from like biblical times or from ancient manuscripts, you will notice they talk about like circles. And so they talk about it in terms of like 3. And, you know, you can research like the history of pi. And pi was found, it's basically if you measure if circumference equals pi times d, and you divide this by d, okay, to solve for pi. So pi is equal to the circumference over the diameter. If you measure really well a circle, the circumference of a circle and its diameter, and you write it as a fraction, you're going to get pi. And so no matter how big or small, but the better you measure it, the closer to pi you will actually get. So that fraction is always pi. And you can get it, the digits, by looking at the wall or looking at the pi key on your calculator. We're not going to really use the 3.14. We'll use the pi key because it's more precise. Now, same with area. You know that to find the area of a rectangle, you know, say that's on a grid, you could count up, you know, all the squares inside of it from a graph paper. Or you can say, well, it's easier just to multiply, you know, like how many squares across and how many squares high to do base times height to find the area of a shape. Well, to find the area of a circle, you want to find out how much is in there. But if you put this on a grid, you'll notice that it's kind of not an exact number of squares that you can easily count. And so what we do is we kind of say, well, look at the radius. If you make this into a square, okay, radius by radius, and do radius squared, how many of those squares would kind of estimate this whole shape? Well, the truth is it is actually 3.14, or pi times radius squared. So to find the area of a circle, you would do roughly 3 of those radius squares, or pi of those radius squared. So the formula for the area of a circle is going to be, it's very much related to the other shapes, it's just pi times radius squared. And so the circumference is pi d, area is pi times radius squared, because of the visual that kind of works with that. Concentric circles are circles that share the same center. In inscribed shape, if you read the sentence, it says a quadrilateral is inside the circle, inscribed inside the circle. Okay, so the quadrilateral is inside the circle. We'll look over to the right. This quadrilateral is inscribed. So it's not only inside, but all the vertices will touch, okay? And so circumscribed is outside. So like circumference is outside of a circle. So a circle is outside the quadrilateral LMNP. And so this could be talked about from 2 directions. The quadrilateral is inscribed inside of the circle. You could also say the circle is outside or circumscribed about outside the quadrilateral. So inscribed means inside, circumscribed means circumference or outside. The last page, the back side, talks about using these formulas to find, you know, different measurements. So if you've got a circle who has a radius or diameter of 18 centimeters, and then if you've got a circle with radius 15 feet, the question is, how can you answer the rest of these questions? Well, let's think about this. If the diameter all the way across is 18, that means the radius is 9 centimeters. And then same with this, if the radius is 15, the diameter is 30 feet. And then they said, okay, let's find circumference and area for each. The circumference is going to equal pi d, okay, 3 diameters roughly, so 3.14 pi key times d. And so if you want to find the circumference of the shape, you're going to do pi times d. The diameter is 18, so you're going to do 18 times pi, and that's centimeters. That's the exact value. And if you use your calculator, you hit the pi key. And so let's see if I can get to that point. Got it on here. No, I've got it on that. you do 18, and then you do pi, and that's going to be roughly 56.5, and that's going to be centimeters. To find the area, we got to use the other formula, which is going to be area equals pi times the radius squared. So you're going to do radius squared and times it by pi. Well, the radius is 9, and 9 squared is 81. And so it's pi times 9 squared. 9 squared is 81 times pi. So it's 81 pi, and that's going to be centimeters squared. All area is going to be in terms of square footage. And so if you've got centimeters, it would be centimeters squared, because it talks about how much space is inside of a shape. I'm only squares. And so these are square centimeters that would fit within the shape that's pictured here. To find that exactly, or not exactly, but approximately, you would put in your calculator, and you would get 254.5 centimeters squared. Now, on the second shape, it says, all right, you've got the radius and the diameter, so circumference equals pi d. The diameter is 30, so it'd be 30 pi. That'd be feet. And then to approximate it, you would do 30 times the pi key, and you would get 94.2 feet. So the exact is 30 pi, the approximate would be 94.2. To find the area, you're going to do pi times the radius squared. The radius is going to be 15, so it'd be pi times 15 squared. So 15 squared is 225, and times pi is 225 pi, and that'd be feet squared. And then if you did your calc, you do 225 times pi, and that is 706.9, and that'd be feet squared. So we're looking to say, if I give you a shape, can you look and take the radius or take the diameter and use it to find the missing pieces? To take pi d to either get the approximate or the exact answer. Take pi times radius squared to get the area, and label it in terms of circumference is always just a unit measure, and then area is going to be in terms of squares. The next portion, we're talking about, give the value of each segment. So it says if WC is 6. If this is 6 centimeters here, we are looking to say, okay, well then what would be XC? Well, XC is also a radius, and so that would be 6 centimeters. And CY is also a radius, and all the radii on a circle are all going to be congruent. So this will be congruent to this, which is congruent to this. They ask you for XZ. XZ, oh, that's all the way across, so that would be 12 centimeters. Okay, so here's where we've got to work backwards. And let's think about our logic of solving. Okay, in the classroom, I had students kind of look at a problem and say, if you've got the problem 10 equals 2x, do you know solve for x? Well, you divide both sides by 2 and you would get x equals 5, okay? Well, the same thing is going to be true for here. They're like, I'm giving you circumference. Can you find the diameter and the radius? Well, whatever they give you, you want to make an equation that talks about what you know and don't know in an equation together. So circumference equals pi d, and so the circumference is 32 pi, and then we don't know the right side. Well, it looks like there's 3 different variables that we've used. The thing is that pi is actually a number. It's like 3.14. It's an exact value. It's not a variable. It doesn't change in value. It specifically represents a specific number. So if you want to solve for d, just like the problem over here on the right, you want to divide by the coefficient. So let's divide both sides by pi. And then if you divide this side by pi, you're going to get the value of d equals 32. So that means the diameter is 32 units. And then that means its radius is 16 units. So you write an equation that talks about what you don't know and know together in a sentence. So if they give you the circumference, well, circumference equals pi d. The circumference is 15 pi. So that equal to pi d. Divide both sides by pi. And that means that d is equal to 15. 15 units. And then this would be 7.5 units. And so write an equation about what you know, circumference is pi d, plug in what you know for circumference, and solve it for the measure that you do not know. The second question we talked about in class like this was over here. If you had 50 equals 2x squared, you would do what? Well, you divide by 2, and you'd get 25 equals x squared. Well, how would you get to plain old x? we could square root both sides, and you get x equals plus or minus 5. But if we're talking about length, we would just go with a positive number, so that would be 5. So we use inverses to help us solve stuff. Well, here they give us the area. So the area formula is area equals pi times radius squared. We know the area is 169 pi. Divide both sides by r or by pi to get r squared. So r squared equals 169. Square root both sides. R is equal to 13, and that's centimeters. Double it to get to the diameter.
Just a reminder, if you are taking the shuttle to ODAC for spring sports, or you are taking the swim shuttle to Chisholm Trail, the bus leaves at 3:06 from the front of the school.
Okay, about that bus. So area equals pi r squared. So if the area is 625 pi, and we want to find the radius, well, let's isolate the radius. Divide both sides by pi, and you get 625 equals radius
For
squared.
any students interested in tutoring after school, there will only be English and language arts tutoring after school today. After school, there is only English and language arts tutoring today.
Okay, so area equals pi r squared. 625 pi equals pi r squared, divide by pi. And so that gets rid of the pi on each side. And then you take the square root. The square root of 625 is 25. And then that's your radius. Double it to get to your hypotenuse, or to get to your diameter. We're going to deal with the hypotenuse in this one. They give you this length to be 12. Okay, top and bottom are 12. They give you the side to be 5. And they said, find the area, find the circumference, find something. So we don't know the diameter. However, this is a right triangle because they say it's a rectangle. So we can use the Pythagorean Theorem where it says 12 squared plus 5 squared equals c squared. A and B are the legs. The hypotenuse is what we're looking for. That's 144 plus 25 equals c squared. That's 169 equals c squared. Take the square root of both sides. C, or the diameter, is equal to 13. So if this is 13, the circumference is pi d. Pi times 13 is going to be the diameter, and that would be in terms of centimeters. And if you want to use your calc to figure out what would that mean, it would be 13 pi. 13 pi. And that is 40.8 centimeters. So I think the big thing is, if you've got to hold on to some of the principles you've already learned throughout this year, where the Pythagorean theorem comes into play sometimes more than not. So EG is 5, and they say it's isosceles. Well, it means both of these sides are 5. And so you could do 5 squared plus 5 squared equals c squared. That's 25 plus 25 equals c squared, and that would be 50 equals c squared. If you divide both sides, or square root both sides, the square root of 50 breaks up into 25 times 2, or 5 radical 2. And so that means that that's the diameter, the length across there. So you do that times pi. So it'd be 5 pi square root of 2. That's inches. And then if you put that in your calculator, 5 pi, and then the square root of 2, you're going to get an answer of about 22.2, and that would be in inches. So you can still use the Pythagorean theorem to help us find the missing parts. All right. Thank you. Have a good day.